So as I promised, now I will bring the most awaited engineering mathematics series. So first let me clear you out that what I will do in this series. If you are searching for some PYQ solving series where someone will just solve PYQs after PYQs after PYQs in one session, 20 to 50 or maybe all the past year engineering maths question, then please don't watch this video. If you are searching for something like this, that there is nothing wrong in that, but you can find easily so many videos for that in YouTube only. But I want to do something different. Now in this video, I will take from 5 to 10 selected problems. And those problems will be obviously from GATE past year questions. And I will not just solve those problems, but I will tell you the concepts that you need to focus on, that you need to memorize for your GATE examination. So your task will be, from this video, you learn mainly those concepts that, okay, this is the concept that I need to learn. Because you see, engineering maths is a vast subject. But for GATE examination, you don't have to learn all the things. You don't have to be a mathematician, but you have to learn maybe in a large chapter like complex analysis, maybe 1, 2 or maybe at most 5 concepts are required. So I will talk about those 5 concepts in these kind of videos. So by solving questions, I want to show you that these concepts are the main concepts which you need to take care about if you want to go for GATE examination in engineering maths. So focus on the approaches and the concepts. In this video, you will get firstly the main concept that is important for GATE, the approaches that you need to develop that will be helpful for GATE engineering maths questions. And lastly, obviously the solutions and the mentality that you must have to solve the engineering maths problem. So a lot of things I have already talked about. Now let me start without any delay with the questions. So here I have taken the engineering maths question from GATE XC 2025 question paper. Okay. So we know that unlike any other branch, GATE XC mathematics is really hard. Okay. And I will take, don't worry, I will take from CS, from ETC, from civil mechanical, every branch, the best questions I will take and I will solve here. So let me start here. So you can see that here is the first question, right? So let me open up another tab where I will mainly solve. So where is notes? Where is notes? Yeah. So that is the notes. Okay. So, okay. Here I will solve and you can see. So firstly, let me read the question. I hope that you can see the question. Okay. So X and Y are two random variables, right? So the question 11, X and Y are two random variables with mean 0 and variance 1. Let me first tell you that mean is nothing but the expectation, right? So I can write that it is given expectation of X equal to X bar equal to expectation of Y equal to Y bar, that is equal to 0. That is given, right? So, and what else is given? The thing is that the variance of X equal to the variance of Y is equal to 1, and the correlation coefficient I will write by rho X comma Y is equal to 1 by 3, and I have to find variance of X plus 3Y. This I have to find. Now let me solve this question. Okay. So here I will solve. So firstly, I'll just adjust the chair. Okay. So firstly, if I am solving this question, see, there is a so-called formula that is, let me write with black color here. Okay. So the solution. So solution I will write here. Okay. Solution. Okay. Again, don't focus on just the solution, but the approach and the mentality. Now here, people take this approach that they use 8ax plus by. So they have memorized this formula, okay, plus b square bar of y plus 2ab into covariance of x comma y. Now there is nothing wrong in memorizing this formula, but if you are like me, then I feel very irritated in memorizing so many formulas. Okay. So what approach I take is I memorize minimum amount of formula by which I can easily derive the remaining formulas within a matter of at max 30 seconds. Again, Remember, if you are thinking that you can derive everything in the examination hall, that is not possible. You can take at max 30 seconds to maximum of 1 minute to derive any formula. Otherwise, because you have 3 minutes to maximum 4 minutes for every question. So if you are taking more than 1 minute for deriving a formula, then you are wasting a lot of time. Okay. So, but if you can derive a formula within 20 seconds from the basic fundamental, then that is way better than memorizing all the formulas. Okay. So if you are like me, in the examination hall, I will surely forget this AB here or maybe this 2 here. So the second approach is you go from the basic concepts. So the basic definition of variance of a random variable is what? Okay. So the basic definition of a variance of a random variable may be A is nothing but the expectation of A minus A bar. Okay, that is the expectation of A or the mean whole square. This is the basic definition. So if I apply this definition for this variable, that is ax plus by, that means var of ax, okay, so a capital X, right, plus b capital Y is equal to, you see, expectation of what? Ax plus by minus, there will be a bracket, expectation of ax plus by, clear, that is the mean, and whole square. Now, basic algebra, I will just rearrange A into x minus x bar. X bar is what? X bar is, I will write here, x bar is E of x. Okay. So I am taking these two terms, this and this. Okay. Now I will take this and this. So this will be plus b into y minus y bar, and there is a whole square. Now I think you can easily see that it is becoming a into x minus x bar whole square, a square obviously, plus b square into y minus y bar whole square plus 2ab into x minus x bar into y minus y bar, right? I think this you can easily see, right? So now, because expectation is a linear operator, and that we have used here also, because expectation is a linear operator, you can write this as a of ex plus b of ey. These things are basic concepts of mathematics. Okay. Now, because again expectation is a linear operator, I can directly write a of e of x minus x bar whole square. And now you know that this is my bar of x. Bar of x. So similarly, this will be b square into bar of y, and the remaining part, that is 2ab into e of x minus xx into y minus yy. So this is nothing but your basic definition of covariance of x comma y. So now you see that in this formula, so you have the actual variable, that is your what? X plus 3y. This is your actual variable. So this will be ax plus by. That means you know that in this formula, you know a equal to 1, b equal to, you know, that is your 3, bar of x equal to, you know, 1, that is given, and bar of y is also equal to 1, that is also given. A you know, that means ab you know, right? Ab is 3. But you don't know this one. You don't know this one. How can you find? Okay. Let me now tell you another basic definition, that is the correlation coefficient. And that is equal to your covariance of x comma y by standard deviation of x into standard deviation of y. And standard deviation is nothing but bar of x. I have to take the root of bar of x, that is the standard deviation. So here that is 1 by 3. And you know that this is 1 and this is also 1. These both are equal to 1. That means covariance of x, now I know covariance of x and y, this is equal to, I will take the precision eraser, and this is equal to, that means 1 by 3. Clear? And now you just put the values, all the values you know here. You see, a you know, this you know, this know, so everything you know, and you will get the answer. See, again, I am not focusing on the answers here. I am focusing on the approach here. So here the message was that don't memorize this formula. Don't memorize this formula. Rather than you memorize this definition. I will just box it out. Okay. You memorize this definition. This you have to memorize. And I will show you one more benefit that you can get from memorizing this. That benefit is to see that again, there is a formula called bar of A. Okay, I will just derive the formula rather than telling you. So this is equal to A minus E of A and okay, let me write formally, very formally, this one, right? Now again, I will just expand it and this will be A square plus E of A, that's whole square, minus 2A into E of A. Clear? And now because again expectation is a linear operator, this will be this. And see, your E of A is a constant. It is already expectation. It is already a mean. So this will be E of A, that's whole square, minus 2 into E of A is a constant. So again into E of A, right? Fine. So that means this is becoming E of A square minus 2 into E of A whole square. So this is equal to your bar of X. Sorry, bar of A. This is another very useful and important formula. Okay, another very useful and important formula. Okay. Now again, if you are like me, sorry, I have made a mistake. Here will be no 2. Okay. Again, if you are like me, I will always forget that if it is E of A square minus E of A whole square, or if it is E of A square plus E of A whole square. So I will surely, I mean, I will surely forget the formula in the examination. But you tell me that from this thing, how much time will you take to derive all the things? So from this definition, okay, from this definition, how much time you have to take to derive this? So I was explaining you that's why I took almost maybe 1 minute, but I can derive it, or you can derive it within 10 seconds. Okay, so take the approach from this session. Okay, so now the next problem. Okay, so again, this problem, if I take, consider the second order partial differential equation, this problem, consider the second order partial differential equation, then which of the following is correct? So again, we have to mainly take care about the fact that for which range of x and y, the PDE will be either hyperbolic or elliptic or parabolic. Now here you will be telling that I have to check for everything, maybe hyperbolic, elliptic or parabolic. So let me tell you, in this kind of examinations like GATE, if you are seeing the same thing in 2 options, maybe hyperbolic in both the options, then there are 70% chances that the answer will be either of this. Okay, I am not telling you that the answer will be surely of this, but that's why we will check the hyperbolic nature first. Now, how you check the hyperbolic nature? Okay, so first I will write here only. So there is a thing called the discriminant. So D is equal to B square minus 4AC. And we know that in this equation, this is your A, this is your B, and this is your C, right? So based on the fact that if D is greater than 0, that will be hyperbolic. If D is less than 0, that will be elliptic. If D is equal to 0, that is parabolic. Now, there is a sound proof for this, but for GATE examination, you don't need that proof. But I suggest you that if you have that zeal or if you have that interest, then go through the proof. Okay. Now, there is a trick to memorize it. So, you see that if D is greater than 0, something is greater, that means it is hyper. So, we tell that don't be hyper, that means don't be angry. So he is going very greater in his anger, in his mood. That's why he's been hyper. So if D is greater than 0, we call it hyperbolic. And if D is less than 0, we call it elliptic. So for equal to 0, so equal to 0 is a very nice thing. And out of parabola, ellipse and hyperbola, we say that parabola is a very nice thing. It it is a very like of the innocent the most innocent curve. Okay. So equal to 0 is a nice thing like parabola, and greater than 0 is being like very hyper, like hyperbola. So these are the tricks for memorizing. You can build your own tricks at it. Okay. So mainly we have to see here that b square minus 4ac, if it is greater than 0 or not for the equation to be hyperbolic. So let us now solve it here, okay, to avoid any kind of untidiness. So here you see that my, okay, I will write it directly. So b is equal to 4 into x plus y. So b square, okay, black color, b square minus 4ac is equal to 16x plus y whole square minus 4, a equal to again 4x square, right? And c is equal to x square plus y square, and I will write here directly 16x square. So I have to see that if this is greater than 0 or not, a question mark. So that means if I just see the sign of this, because 16 is I can take common, right? Then it will be okay. So I have to check that if this is greater than 0 or not. Again, I am taking a interrogative sign because I don't know if this is greater than 0 or not. So if I expand this, this will be, okay, y square, right, plus x square plus 2xy minus x to the power 4 minus xy whole square, if this is greater than 0 or not, right? That means what I am doing is I will convert it into a quadratic in terms of y. So quadratic of y. So y square into 1 minus x square by taking these two terms, by taking this term and this term. Okay. So this one, okay, plus 2xy plus x square into 1 minus x square, okay, is greater than 0. So first of all, you have to see here that this expression is a parabola in y, that is a second order curve in y. So this expression have to have greater than 0 if it has to be hyperbolic expression. So if I compare it with a form of ax square, like a general second order curve, plus this is equal to maybe fx. Okay. So if this has to be positive, the first thing is that at least this has to open up. This has to open upwards. This has to open upwards. If it is like this, then for some value of x and y, it will be yes. Then for some value of x and y, it will be negative. So first of all, it has to open up. It has to open up, right? So yeah, this curve will not okay. So if it has to open up, then for this kind of equation, if this has to open upwards, then we know that a must be greater than 0. So by applying the same analogy here, this is the small a. That means 1 minus x square must be greater than 0 if the curve is hyperbola. Okay, I mean if the equation is hyperbolic. That means mod x is mod x is less than 1. That means x has to lie between 1 and minus 1. So this is my range for x if the equation has to be hyperbolic. Other than that, you have to check. Now this is your homework. So you can easily find the minimum value of this. So I'll write the minimum of x, fx. How can you find? You have to just dd, okay, d of dx equal to 0. The same thing you have to do here. So if I call this as another function as g, okay, so again you have to do one thing, that is g of dg of y, because here the independent variable is y, right? So again here you have to do this 0 and you will get that y equal to something, and then you can get some y minimum, okay, some y minimum, sorry, some g minimum, I should say, some g minimum, okay, some g minimum. So here you have to see that for what value of y, okay, or let me solve this question. right? Let me solve this question. Okay. For you, let me solve this question. So for this kind of curve, I cannot memorize anything. So that's why I have to do it. So df dx equal to 2ax plus b equal to 0. That means x is equal to minus b by 2a. Clear? So here now you can you can say that I should check this second derivative. So the second derivative is equal to this, and this is positive if my a is greater than 0, and I have already told that my a is greater than 0 because my parabola has to open upwards. So that means this is my minimum value. This is my minimum x value. So my x min is this minus b by 2a. And here my f min will be what? F min will be a into minus b by 2a whole square. So b square by 4a square, right? Plus and b square again. So here it will be minus b by 2a. Minus b square by 2a. I am just putting this x minimum into this equation plus c, right? Plus c. So here you will get some value. Now you see that this minus b by 2a, and here this is the b here. So what I will do is I will just copy this equation. Okay, copy and paste. Okay. Okay. So here again, my I should say my y mean is equal to minus b. So here b is what? What? Minus 2x. Sorry, b is 2x. So minus b by 2x. So 2 into 1 minus x square. 1 minus x square, right? So here this one. Okay. So you see that if my x, so now let us see the options. Okay, let us see the options here. So you see that for this option, for the first option, they are saying that if x is having this range, so this range is obeying that value. That is my x has to be between this. So this range is obeying that value. That means this can be hyperbolic. However, I have to check this value. Okay. So my y mean is here. You can see that y mean, okay, or I should say, yes, my y mean here is always negative. Okay, because if my x is positive, according to the first option, my x is negative. Sorry, my x is negative. So my y mean is positive because my x is negative. That means my y mean is positive. Okay, my y mean is positive. But that doesn't matter. Y can be always less than 0. Okay, so you have to understand this y mean, this is not equal to the minimum value of y. This is the value of y for which this whole expression, that is equal to g, that g will be minimum. Okay, so this g will be minimum, not this y. Okay, so this y mean is this, that is perfectly fine. Okay, now ideally you should also find the range for y. Now this PD is hyperbolic in the region if, see, this is wrong because you know that x has to be less than 1. Now this PD is elliptic in the region if it is this. Okay, so if it can be elliptic, can it be elliptic? No, it cannot be elliptic because for this one we see that the parabola is upward open. So if the parabola is upward open, that for some value of y, this will have a positive value, right? Yeah. For some value of y, this will have a positive value. And if the PD is parabolic, again, you have to show that if it, so now this is your homework, that you have to show that if this is parabolic, if this range is occurring, that is x greater than 1, then if it can be 0 or not for this. Okay. So this can be easily shown, but here this will be the answer. Just by seeing this thing, you can say that this will be the answer, and by seeing this thing, this cannot be hyperbolic. Okay. So this was the question in which your only thing that you memorize always, that is my d is greater than 0 is not enough. Your basic understanding of mathematics is required here. Your basic understanding of mathematics. Okay. This was a beautiful question. The next question is of convergence series, divergence and convergence of series. Now, I don't see often these kind of questions of series in GATE examination. So, what I suggest you is, you right now, I will explain this question, but you just see that how to uh, how to judge convergence of series, of a series. Okay, there are so many tests. First is a ratio test. Second is a power test. Third is a comparison test, and fourth is an integral test. Mainly these kind of tests are there, and you just learn these tests. Okay, so here I will apply one of these tests, and one very easy method is, so now let me solve it. Question number 13. So I will just write the series here. So P is summation of n2 plus 1 n log n whole to the power 1 by n, and Q is summation of n equal to 1 infinity n to the power n by 2n factorial. Now you have to first understand one thing. When I say that the series is convergent, I say the series is convergent when the summation of the series is converging into a finite value. That means if we take that, I say that this is my an. So for P, I will first do it for P. For P, my nth term an is equal to this. So if you see that your limit n tends to infinity, an is something other than 0, then the series cannot converge by any means. Okay, because if the infinite there is a very large term that is also not 0, that means something will keep adding up, that will go to infinity. Okay, so here this is a basic concept. These are not the formal talkings about the series. You must refer to any good book if you want to know some formal theory. But I would suggest you that go for these 4 tests, that will be enough. And obviously you have to practice, because just by seeing the question paper for the first time, you cannot say that for this series I will apply the ratio test, or for this series I will apply the integral test. You have to have some experience. Okay. So here you see that if I have to apply the limit for this an, this is a bit hard because here it is n log n 1 by n. So what I will do is I will define Dn as log an, and that is equal to minus 1 by n, okay, into log of n log n. Clear? Now I will apply limit n tends to infinity for Bn, that will be limit n tends to infinity. So minus I will take here, and this is log n log n by n, and this is infinity by infinity form, so we can apply the L'Hopital's rule. So I will do the derivative for the numerator and the denominator. For the denominator it is 1, for the numerator it will be 1 by n log n into what, log n plus 1. Okay, you can do these kind of calculations by yourself always. These are just the basic calculations. And now this will be log n plus 1 by n log n. And now if I just break it down or expand it, it will be 1 by n plus 1 by n log n. Okay. You see, as n is tending to infinity, both of these terms are going to infinity. Sorry, I mean both of these terms both of these terms are tending to 0. Because n is tending to infinity, that means 1 by n tends to 0, and 1 by, so n and log n both are are tending to infinity, that means this will go to 0. That means limit n tends to infinity bn, and that is nothing but my log a, this is going to 0. That means limit n tends to infinity an is going to 1. So again, there is a huge chance of silly mistake that if I am saying that this is going to 0, that means this is convergent. No, that means n is going to 1, that means this is not equal to 0. That means p is not convergent. Okay, not I'm writing COND, p is not convergent. So that means if I now see the options, this will not happen, then both converge, p converge, not happen. Okay, now I have to see that if q is diverging or converging. So now what is my q? Okay, now I will go for q. So for q, again, if you do the same thing, that is your limit q, okay, where q is given as. So if I try to do the same thing, an, but here an equal to your n to the power n, again 2n factorial. So it is very hard to apply some limit in factorial. So here I will apply the ratio test. So what does the ratio test say? The ratio test say that I will define a radius of convergence rho that will be my limit n tends to infinity I will write a of n plus 1 by an. So if my rho is less than 1, then it is convergent. If it is greater than 1, it is divergent. If it is equal to 1, it is, if it is, yes, it's fine. If it is equal to 1, then it is undeterminate. Okay. Similarly, for this power test also, we define another rho. For this comparison test, we compare it with another series. If that series maybe some another series Bn, if Bn is larger than An, that means if Bn is larger than An, and if Bn actually converges, then I can say that An actually converges. So this is the comparison test, and the most powerful and easy is integrators, that you can see by yourself. Okay. So here, let me find out this. So this an plus 1 by an, so that will be n to the power, n plus 1 to the power n plus 1 by 2 into n plus 1 factorial, this whole factorial, mind it, into 2n factorial by n to the power n. So now you see, this term I can write n plus n whole to the power n into n plus 1, right? So by n to the power n, right? Now into 2n factorial means what? 2n into 2n minus 1, right? Into dot 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 up till 1 by 2 into n plus 1 factorial means 2 into n plus 1 into 2n minus 1 into 2n factorial. This we know. And this is again 2n factorial here, so I can cut it down. Okay. So that means this will be n plus 1 by n whole to the power n into 1 by what? This will be plus 1. 1 by 4 n, or 1 by, this will be cut, and 2 into 2n plus 1. So I have to take this limit n tending to infinity, this whole thing, that is n plus 1 into 1 by this one. So you see that this goes to E. When n is tending to infinity, this goes to E, and this goes to 0. Okay, that means this will be tending to 0, because 0 into E is 0. So my rho is equal to 0, that is less than 1. That means my Q is a convergent series. So my answer is this one. Sorry about that. Okay, now this question 14, this is damn easy. This is a class 10 level question. That is, suppose the polynomial interpolates the data. This one. So these are the 4 sets of values xi, yi for I equal to 1 to 4. 1, 2, 3, 4. and this function is fx. So you have to write f of yi, sorry. So you have 4 equations, yi equal to f of xi for I equal to 1 to 4. 4 equations and 4 unknowns are your A, B, C, D. 4 equations, 4 unknowns, solve for A, B, C, D and see the correlations. Okay. Now this one, I will solve 2 more problems. Okay. Now this one is very interesting. So here, or let me see if more interesting for problems are there. Okay, I'll solve that one also. Okay. So why did I shut off that thing? Okay. So question 15. So let's see with the positively oriented boundary. See with the positively oriented boundary of the domain bounded by the curves y equal to, so I hope that you can see this question. So if I draw the graph here, then my y equal to 2x square will be something like this, and my y equal y square equal to 4x will be something like this in the first half. So my c is this one. C is this one. Okay, this one is C. So I have to find this integral here. This integral here. So firstly, let me write this integral and I will solve it here. So 2y square plus 2xy plus 4y x square plus 4xy plus 8x for C. Now again, this problem is actually very easy. How? So this is a direct application of Green's theorem, but there is something more to say. Okay, that is, if I can write this as C is equal to, so why I have shut that window off? Sorry, extremely sorry about. Okay, so okay, so now this I can write as u dx plus v dy. Okay, so Green's theorem says that this is equal to integral over the area, or I should write the double integral over the area, and that will be del v del x minus del u del y into dx dy, and this area will be this area. This area. This is the A over A. Okay. Now you see that this you can easily solve, right? Still, let me solve this for you, but there is a message. There is a more important message. So this will be equal to, again, del v del x is what? 2x plus 4y plus 8, right? So minus of del u del y equal to 4y plus 2x plus 4, right, into dy dx or dx dy, right. So this will be, you see this I can cut. So 8 minus 4 is equal to 4. Okay, so 4 into area. 4 into area because 4 into integral of dx dy. Now this area is very easy to find. So this area will be, if I take an elemental strip here of thickness dx, then this area will be what? This area will be height, that is y1 minus y2 into dx from 0 to 1. Because this is 0, this will be surely 1, you can check. And this is my y1 and this is my y2. Okay, and this is you have already given. Sorry, I think, where was the question? Question 40. No, sorry. Extremely sorry. Where was the question? Yes, this was the question. Okay, this was the question. Okay, so again, this will be your y1 equal to 2 root x minus 2x square into dx. So this you can easily find, right? So here, but one more thing, if you are like me, then you will surely forget that if it was du dy minus dv dx or dv dx minus du dy. So how can you memorize this? See, there is a more generalized theorem called Stokes theorem. And what does it say? If I have a vector v, then the contour integral of a closed contour C is equal to the area integral of curl of v dot nda. Okay, dot nda. You see that here, if I take my v is equal to ui plus vj and my dr is equal to dxi plus dyj, then again I just come back into this equation. Sorry, I just come back into this equation where this is my u and this is my v. Okay, so and if you follow this approach, then you will never make the mistake in calculating curl of v, because you know the definition of curl of v, right? Del x, del y, and uv, and here it is k cap, del z, here it is 0. So then you will never make the mistake in calculating curl of v, and you will never make the mistake that if it was del v del x minus del u dy or del u del y minus del v del x. Okay, so this is the more general approach. And if you are a student of fluid mechanics, then this is nothing but circulation, and this is nothing but your vorticity. Okay, so circulation is equal to vorticity into area, loosely speaking. This is something that we all know if we have studied fluid mechanics. Okay, so here this was the approach, that memorize the Stokes theorem, Green's theorem, you can automatically derive. Okay, now this is a very easy problem, and this is a very, formula derived problem. Okay, so I will solve this in maybe in the next session. It is very easy. So this is actually nothing but your, I should write Cauchy-Euler equation. Cauchy-Euler equation, and this equation has got a formal mechanical technique to solve. Okay, but here I will again solve, and this is very easy problem. Okay, I will tell you to solve this. You can take a screenshot. Okay, solve this. Okay, I will solve one more problem, and that is this one from the complex analysis, and this is a beautiful problem. Okay, so what does it say? It is saying that fx be an analytic function. Okay, fx be an analytic function, and real part of f dash of fx not fz. So this will be 3x square minus 4y minus 3y square, and it is giving f of I is equal to 0 and f dash of 0 is equal to 0. I have to find f of 1, right? So let me solve it. So here one thing is given. Again, every time I am just putting this off. Okay, one thing here is given, that f is analytic, and this is the thing, this is the key, this is the pivot point from which you have to solve this. So the solution. So you see, fz is analytic. Okay, that means my f dash z will also be analytic. Now, no matter if you like mathematics or not, I will suggest you to look back upon that what is analytic. Analytic means that if this function will be analytic over a particular region, if I can find the derivative, if it is differentiable over that region. So if f is differentiable over a particular region, then it is analytic. Okay, and obviously if the it has to be continuous. Okay, so now if it is analytic, then there is something called a Cauchy-Riemann condition. What does that say? So f dash z, I say this will be some p plus I cube. By the way, in every complex analysis question, z is equal to x plus I1. This you have to know. So if dash z is equal to p plus iq, then because if dash z is analytic, then from Cauchy-Riemann condition, I can say that my del p del x is equal to del q del y minus, and my del p del y is equal to del q del x. Okay, this is the Cauchy-Riemann condition. Again, if you are a student of fluid mechanics, I have my complex potential function fz equal to phi plus I psi. Phi is the velocity potential function, psi is the stream function. So this is nothing but your u. If I put instead of p psi phi and instead of q psi, this will be your u. Sorry, this will be your u, this will be your v. If you are a student of fluid mechanics, you know this well. Okay, so this is something that you need to memorize for GATE, that is the Cauchy-Riemann condition. I will give a box here. Okay, that is the CR condition, not Cristiano Ronaldo. Okay, okay, so now here we know that we are given this as, right, this as my real part of f dash z, that is my p. Okay, so this is nothing but my p, because f dash z is equal to p plus iq. So from these equations, I can say that my minus del q del y is equal to del p del x, and that is 6x. So here my q is equal to minus 6xy. Okay, minus 6xy. Actually, in the Cauchy-Riemann condition, it doesn't matter, but here this will be plus, this will be minus. But actually, it doesn't matter. Okay, it will matter less, because you can always interchange the sign by interchanging the notions. Okay, if you can see the derivation of Cauchy-Riemann condition, you can understand it, and I will suggest you to go through the derivation of the Cauchy-Riemann condition. This is important. Then you don't have to memorize the Cauchy-Riemann condition. You can always derive it easily, and the derivation is actually easy. Okay, so here it will be plus 6x plus some function g of x, because I'm integrating with respect to y. Also from the second condition, minus del q del x is equal to del p del y. Del p del y is what? Del p del y is minus 4 minus 6y. Okay, so here from this I can write q is equal to what? 4x plus 6xy plus some h of y. Okay, now from this equation, these two equations, also I can write, okay, that my gx is equal to 4x and my h of y is equal to another, I mean this 6xy. Okay, uh, okay, or I can write that I don't know this h of y. Okay, I don't know this h of y. So I can write that my q is equal to 4x plus 6xy plus some capital G of xy, maybe xy. So how can I find this capital G of xy? See, I have one more thing, that if I now know my q, that means my f dash z will be p plus iq. So my p is equal to 3 of x square. Let me see from this here. I have the question paper, that is 3 of x square minus 4y minus 3 of y square plus I into 4x plus 6xy plus h of y, right? So my f dash of 0 is equal to 0. So f dash of 0 is what? Everything will be 0. So only h of y that I don't know, that will be 0. That means my h of y is equal to 0. Okay, that means this is equal to 0 and my q is equal to 4x plus 6 square. So that's why that f dash 0 was given. Okay, so now I know my p and q. Let me again write my f dash z. Okay, so my f dash z is equal to, right here clearly, 3x square minus 4y minus 3y square, right, plus I into 4x plus 6xy. So now there is a trick. Which trick? So there is not a trick. I can always say that the next step is to convert this not in terms of x and y. This is now in terms of x and y. You have to convert this in terms of z. For that, I know that z is equal to x plus iy. Okay, because you know f dash z, so you have to integrate it. So z is equal to x plus iy. So let me square this out. This will be x squared minus y squared plus 2i into xy. Okay. So if I multiply 3 here, then it will be what? I into 6xy. Can you find this expression in this expression, in the above expression of f dash of z? Yes, I can find. That is 3x squared minus 3y squared plus 6xy into I. That means that will be my, so let me write it here. So let me write it here. So this will be my 3 into z squared plus what are remaining, that is I into 4x minus 4y. So in this expression, let me do some modification. If I take I into 4 common, that will be x plus iy, because 4iy into iy, that is minus 4y, right? And this is equal to z. That means my f dash of z is nothing but my this one plus I into 4z. Sorry for that. That means my fz will be equal to 3 by 3z cube. I am integrating this into z square by 2 plus some k. And now I know my fi equal to 0. So my f of I is equal to I cube, that is minus 1, plus I squared, that is I cube is minus I. And here 4i into I square, that is minus 1. So that will be minus 2i. Minus 2i, right? Plus k, that is equal to 0. That means my k is equal to 3i, right? So if my k is equal to 3i, that means I am getting my fz equal to z cube plus I into 2z square plus 3. I have to find f of 1. So f of 1 is equal to 1 plus I into 5. So I 1 plus 5i. Yes, option B is the correct answer. So here the main takeaway was the Cauchy-Riemann condition. I will not solve more problem here. I will tell one more thing from complex analysis that is very important. That is the Cauchy residual theorem. If you have an integral like this, f of z, okay, f of z dz, okay, over a contour C, then that will be equal to 2 pi I into summation of residuals of f at z naught or at zi for I equal to 1 to n, where the zi's are the poles in the contour C. Okay. And how can I find the residual of f at zi? That is nothing but your limit z tends to zi, right? Z tends to zi 1 by n minus 1 factorial 1 by n minus 1 factorial into d n minus 1 dz n minus 1 into f of z into z minus zi whole to the power n. Yes, this is an ugly formula, but this is very important formula. And believe me or not, Cauchy-Riemann condition and Cauchy's residual theorem. And there is one more thing that is called Cauchy's integral theorem. And this is, we call that this is the residue theorem. Okay, so integral theorem, Cauchy's integral theorem, residue theorem, and the Cauchy-Riemann condition. If you understand these three in complex analysis, I can say that with 90% probability, you can solve any question. At least from mechanical, civil, CS, easily you can solve. I mean, if not from XC, because XC can ask some more in-depth question. Okay, but these three are the main things of the complex analysis for GATE examination for any branch. Okay, so you can always see this Cauchy residual theorem from any book. Now I will stop this video here. Let me tell you again, let me remind you again. The purpose of this video was to make you aware about the concepts which are particularly important for GATE. That is, from complex analysis, you can so you can now start studying the complex analysis, and it will take at least some week, at least 1 or 2 weeks. I mean, that is also if you are studying continuously. But you can study only these three concepts. That is the concept of Cauchy-Riemann conditions and the concept of analytic function. These are correlated. Concept of Cauchy's integral theorem and concept of residual theorem. If you can study only these three, you can ensure that your complex analysis is almost done for GATE examination. Likewise, for all other things, like I have already shown you that how to use the Stokes theorem to derive the Green's theorem, how to use the definition of variance to memorize two formulas at simultaneously at a time. So I will take up five more questions in the next video, and I will continue this series only if I get positive response in the comments, and if you share this video, like this video, and subscribe my channel. Okay, itna to banta hai na. So if you are thinking that this guy is doing something for you, then please do these things. Okay. So until the next engineering maths video, goodbye, take care, thank you, and stay awesome.